Mars. So we've been talking about Ingenuity and this amazing little, like just under 2 kilogram helicopter. It's about 40 odd centimeters high. So it's really, really tiny. The rotor blades on it, on the helicopter, and don't forget, these are having to spin at a terrific rate and lift the weight of the helicopter on the off the surface of Mars when you've got an atmosphere, significantly less. You were talking about 100 times plus less than the density of the atmosphere on Earth, and it's got to lift off. So that's complex enough in its own right. But Mars has been plagued, and we've known this from the early part of the space age, even before the space age, when we were looking with telescopes, when features would disappear for entire seasons, as it were, and the astronomers at the time were looking through their telescopes and trying to work out what was happening. And it's these dust storms. You get planet-wide dust storms on Mars. There's known seasons when this happens, etc. Now, as Mars is approaching its Martian winter, as it were, the temperature's obviously dropping, and the propensity for these dust storms is kind of on the increase. And what's happened is that Ingenuity, brave little helicopter, basically shut down for a couple of days. The interesting and I think funny thing with this is it shut down between May the 3rd and May the 5th. And I think it was just having a day off for Star Wars Day. This is May the 4th be with you and all that business. But essentially, just before this, it had managed to image the back shell and the parachute from the Perseverance lander, which the images, literally, I had hairs on the back of my neck. It's goosebump stuff, and people saying, "Oh, it's littering the solar system." No, this is, as Stuart Atkinson, I think, said, it's kind of archaeology waiting to happen. It's a space tourist thing waiting to happen. We're going to visit these sites one day. We're going to visit the sites of Viking, and even going back to the early Soviet, the Mars 3 lander. We kind of know where it is now. We think we know where it is from the amazing images from HiRISE. Anyway, so Ingenuity shut down for about 2 days. This is principally because it didn't have enough power to charge its battery. So it's got 6 lithium-ion cells. Basically, they're using what's called COTS, common off-the-shelf parts. It's an amazing helicopter in terms of its design, but also the fact that it's nothing special in terms of the electronics and gubbins that are on it. It's common off-the-shelf technology that they've kind of thrown together. It was only designed to last for 30 Martian days or 30 sols. It's now over a year in. Don't forget, Perseverance landed last February with this thing strapped to its underbelly, dropped it down on the surface, rolled away. Initial tests, they didn't even know it was going to fly. 28 flights later, it's still going strong, and thankfully is still going strong. NASA thought they'd lost it for a couple of days. Then essentially what had happened is a lot of dust had built up on the rotors. So the rotor blades are also the solar panels. And if you think about the size of it, it doesn't have much of an area to do this recharging. So it recharges over a period of like days, etc. But obviously with the Martian winter coming, you've got less solar radiation hitting it, and you've got more dust. So it is a problem. One solution, we were talking about this just before we went on air, would be possibly in a future mission, if you were going to do the same kind of thing, where you've got a pairing of a helicopter, helo, and a rover, having almost like a gas compression capability on the rover that could absorb some of the Martian atmosphere and compress it and then act like a blower, so it could trundle over to the helicopter and blow the dust off if it got a bit too much. But yeah, they're having to survive this Martian winter. It's going to prove to be really difficult, and NASA don't know if Ingenuity is going to survive. Obviously, Perseverance, nuclear powered, totally different ball game. It's fine. It can switch its heaters on. It can maintain its stable temperature even during the depths of the Martian winter during shutdown. Effectively shut down. It can still carry on. Obviously, with Ingenuity, they can't do this. So they're looking at the best way to solve this problem. And what they've done is they've reprogrammed it. Again, beautiful technology. Reprogrammed it so the battery's kind of lowest point, as it were, before they go into a critical state has been lowered. So the heaters don't kick in and therefore sap the energy that it has got from the solar radiation and from the solar panels too soon. And I just love the fact that they've got around all these problems. Programmable FPGAs, field programmable gate arrays, that's a chip, the kind of brains of the helicopter, being able to reprogram that and reprogram all of the memory on board, and then re-establish this communication after they've re-established the communication after 2 days. Been able to do this. And then the beauty of Ingenuity is it's relaying kind of quite low data rates back to the rover, which is then relaying that back up to the deep space network from the surface of Mars. Again, that's an incredible feat in itself. I don't know what you think, Terry. I love this, that it's solving problems at these extreme distances with basically a bunch of parts that you could buy at Maplin if it still existed.
Yeah, they're brilliant at NASA, basically in problem solving at a distance. I think it started basically with Apollo 13, whenever they had to rescue the spacecraft from a nearly crippling explosive disaster. Just on this point, there's both pros and cons of the Martian winter. If they do want it to fly again, and I presume they will at some stage, the colder air actually is denser. So that gives you slightly more lift from the rotor blades. Now, obviously, if you haven't got enough power to power the motor, you don't do it. But if they are going to be doing more flights, and I presume they will at some stage before the depths of the winter, the slightly colder air gives them that little bit more lift. So there's a little bit of a pro as well as the cons whenever the temperature is dropping and the angle of the sun and the amount of solar radiation is dropping as well. So it's not all doom and gloom. But as you say, it's absolutely amazing what they can do from a distance. They program in basically the ability to do upgrades and changes to the software. Because they know that things that can happen that you don't expect. You expect the unexpected in space missions. So well done to the guys and
Yeah.
girls.
Yeah, and you say that it's not that long ago that spacecraft weren't designed to have this reprogrammable capability.
Yeah.
You're only looking, a few years ago where you've really had the whole ability to reconfigure a spacecraft to do a number of different jobs, specifically in low Earth orbit. Now that's really taken off where you've got, completely reprogrammable satellite capabilities. But as you said, I mean, it goes back to Voyager as well, being able to reprogram Voyager and spacecraft that have gone out when they had issues with telemetry on Galileo, etc. Being able to reprogram and change the data rates and change the way that the transponders worked, it's amazing. And then again with Voyager, just okay, this is not working now, or this is going to draw too much power. Let's shut this down. Keep the critical instruments going to the point where we're going to have Voyager 1, Voyager 2 potentially running for at least another 4 or 5 years, which will be 50 years or 40, 50 years, 50 years since launch, using computational technology that was designed in the early 1970s. It's just, yeah, hat tipping. It's amazing. They really are just quite incredible. So when people moan about their computers going wrong at home, yeah, just try fixing something that's years old anyway at that distance. Anyway,
There's
moving on.
there's a
Oh, go on.
question.
Go
Do
on.
you want
Yeah.
to answer perseverance and ingenuity part independently? Why keep them together? Well, as you say, ingenuity needs to send at a very low data rate back to perseverance, and then it can send at a higher rate back to Earth. But yeah, I mean they're separate, but they can't get too far apart.
Yeah, and the other question about could Ingenuity hibernate? The issue is the temperature. The temperature drops so much that you're causing potential damage. You've got to keep the electronics above a certain temperature, so they've got to have heating systems that can look, like with Voyager with the RTGs. They've got to maintain a core temperature in the system. If it goes below a certain point, then effectively the spacecraft will die and it won't be able to recover, even with solid state electronics. Obviously, again, it's a good point though that you've raised about the distance between them, because what you could have again is almost like a jump start boost, as it
Hmm.
were, from the main rover. So if they're not too far apart, being able to trundle the rover over to Ingenuity and having almost like a small docking port, as it were. You'd think of R2D2, for example, in the Star Wars movies, where you kind of had that little probe that you don't want to have USB cables or anything like that, but something simple that you can almost jump start it, again, would be an interesting idea for future missions if this kind of power issue is going to be a problem.